In simple words, the function is the dependence of one quantity on another. Let's look at an example. Let's assume that your parents allow you to play a computer game for 1 hour a day or 60 minutes, but only after you finish your homework. And for one mistake that was made in the homework, your playing time in a computer game is reduced by 5 minutes. If you don't make a single mistake in a homework, then your playing time won't change. I'll multiply 5 by the number of mistakes and subtract it from 60 minutes. If you make one mistake, then your playing time will be reduced by 5 minutes. I'll multiply 5 by the number of mistakes and subtract it from 60 minutes, so you have 55 minutes left to play a computer game. If you make 3 mistakes, then your playing time will be reduced by 15 minutes. I'll multiply the number of mistakes by 5 and subtract it from 60 minutes. I hope you understand the principle. I can write down a formula for calculating your playing time in a computer game. Time is usually denoted by the letter T, and this time of playing on the computer game depends on the number of mistakes you make in a homework, and this number of mistakes doesn't depend on you. But the time you'll play in a game depends on the number of mistakes. The more mistakes you make, the less time you have left to play a computer game. And this is a function when one number depends on another. And in general, the function is denoted by the letter f, and the letter f will mean some mathematical or algebraic expression. N is an independent variable, and time t depends on the variable n. And in our example, f will represent the algebraic expression 60 minus 5 multiplied by t. Here the variable n can take values from 0 to 12. If you make 12 mistakes, you won't play anymore, because with 12 mistakes, the game time will be equal to 0. Of course, you can make more than 12 mistakes. Let's say 13, but then we get negative time, and for our example it won't make sense, because the game time can't be negative, and the minimum time is 0. And these values of the independent variable which we can substitute the function are called the domain. And the values of the function which are obtained when we substitute all the values of the domain will be called the range of the function. In our future lessons, we will consider the function variable y depending on variable x. For example, I will write down a couple of such functions. Please remember that in such functions, instead of the independent variable, we can substitute absolutely any values, and we choose these values such as we like or such as we think will be convenient for our calculations. In this function, we can also substitute absolutely any value instead of x except 0, because you can't divide by 0. And if you see such a record, it means that the independent variable takes a certain value, in this case, 4. And to get the value of the function, we must substitute this value instead of the independent variable into the function, do the calculation, and get the value of the function, or the value for the variable y. Now let's look at examples. We have a function set, and we need to calculate the value of the function for certain values of the independent variable. To raise the number to the second power, we need to multiply this number by itself. With this multiplication, we always get a positive number. Since the negative number is multiplied by the negative number, we get a positive number. And with the multiplication of two positive numbers, the result will also be a positive number. We substitute the negative 5 into the function instead of the variable x, raise negative 5 to the second power, and get 25, subtract 9 from 25, and we get 16. We substitute negative 4 into the function instead of the variable x, raise negative 4 to the second power, we get 16, from 16 subtract 9, we get 7. We substitute -3 into the function and get 0. We substitute 0 into the function and get -9. The next number we substitute into the function is 2. We get a -5. We substitute 3 into the function, subtract 9 from 9, and get 0. 6 raised to the second power is 36. Subtract 9 and we get 27. Now let's write a function to find the volume of a cube. And the volume of the cube, of course, will depend on the length of the edge of the cube. The height, width, and length of the cube shown in the picture are equal to 4 cells. And in order for us to calculate the volume of this cube, we need to multiply 3 dimensions of the cube. This threefold multiplication of 4 is equal to 4 to the power of 3. And is equal to 64. And now, in order for me to find the volume of a cube with an edge length equal to a, I need the edge of the cube and raise it to the third power. As you can see, in general, I wrote down the formula for calculating the volume of a cube, but this will be the function. And here we have the volume of the cube depending on the length of the edge of the cube. In this example, you need to find the value of the function according to the function graph. On the x-axis from the point -3, we draw a perpendicular to this axis until the intersection with the function graph, and we draw a perpendicular to the y-axis, and we get the value -2. We have 2 cells corresponding to 1 on the axes x and y. Divide it all by 2, and we get that 1 cell will correspond to 0.5. So -1.5 will be here. We also draw 2 perpendiculars, and this point will be 0.5. Next, we draw a perpendicular from this point, and this value is 1.5. When x is equal to 0, the value of the function will be approximately 1.6, 1.7. For the value of the independent variable 0.5, the value of the function will be 2. And for 3.2, it will be about here. We will get the value of the function -1. That's all for today. Subscribe to the channel. Bye everyone.